Howdy, we're Team 6 and we're doing the Dolphin attack. Our project's target is the voice command systems found on personal devices, such as smartphones and tablets. Voice command systems and assistants have become a staple portion of these personal devices and have grown in their ability to perform tasks with limited user interaction. As a result, voice command systems have become attractive targets since the malicious commands can do serious harm relatively inconspicuously. This attack aims at communicating malicious commands to the target device inaudibly by means of ultrasonic amplitude modulation. The nonlinearity present in the microphone in these devices then demodulates this signal, allowing for it to be interpreted normally by the target device. This in turn allows for execution of malicious commands on the device as if they were spoken by the target user without their knowledge. The attack will be performed in two ways: hardware and software.
With regards to the hardware implementation of our attack, our first attempt was to create and play back modulated high-frequency audio files. We created the files using MATLAB and Audacity by using the desired audio message to amplitude modulate the ultrasonic carrier frequency corresponding to the target device. The resulting waveform was then converted to a high-frequency audio file and was played back using a high-frequency audio player on a phone with high-frequency audio support, connected to an ultrasonic transducer. This did not work, however, as the output spectrum measured from the phone did not match the spectra generated in MATLAB and Audacity, meaning that there was an error along the way that we were unable to diagnose. Our next attempt was to use an Analog Discovery 2's built-in waveform generator to produce the modulated output, which was able to do using the amplitude modulation function in its software. This worked somewhat, but the Google Assistant was only able to occasionally recognize the modulated words "Hello Google," even under ideal conditions and at a 2-inch range on the target device. We believe this is due to the high frequency artifacts that were also being demodulated by the microphone, which seem to be caused by the limited sampling rate of the Analog Discovery software. Furthermore, some garbled audible noise could still be made out emanating from the speaker. Our attempt to rectify this problem was to use an analog multiplier to perform the amplitude modulation in analog hardware in order to overcome the sampling limitations of the Analog Discovery 2. This was successful and no more demodulated high-frequency noise was observed. Using this method, the Google Assistant was able to recognize the modulated words "Hello Google" consistently at a range of up to 12 inches. However, the issue of being able to hear some garbled audio from the speaker was not fixed and may be due to non-linearities in the ultrasonic speaker itself. Charles will now cover the software implementation of our attack.
As an example of the software portion, as a result of the project, we have uploaded several of the .im files used to create the following files, which are samples of the completely unmodulated and unaffected normal audio. For example, this portion of "Hey Siri."
Hey Siri.
This is then modulated on a 26.5 kilohertz cosine, almost inaudibly, as it should be.
Hey Siri.
And then demodulated after it goes through a mathematical model of a microphone. The only failings of this portion are that there are a slight pop audible in the modulated and demodulated signals, which kind of affect how the signal sounds. However, it's not catastrophic. As one can see by these graphs, the time domain signal here on the top left is the completely unaltered version, whereas the time domain signal on the top right is the unmodulated signal. And they seem extremely similar, as they do in frequency below themselves. You can see the modulated signal in the middle, very cramped in time, and a very large peak at a much higher frequency than present in the other two, which shows that the attack is working as anticipated in software.
So the hardware setup for this attack, the first component is the Analog Discovery 2 software, which on one waveform generator channel has the input audio, and on the other channel has the modulation frequency. Then we have the Analog Discovery 2 itself, the waveform generator channels of which is connected to the analog multiplier, which performs the actual amplitude modulation, and the output of that is connected to the audio amplifier, which is connected to the ultrasonic speaker. Next, I shall demonstrate the attack.